Now here in example 33, we have, they're asking us to graph f of x, which is the absolute value of x on the grid, which we have here. And now the question is, does gf -2 equals g -2? And we got to explain using the graph. Well, what does this mean? This means that in the function f, which has been defined as the actual value, and function g, which is defined as -x squared plus 2, are they equal? Are they equal at x equals -2? This is what this expression means. Does f -2 equals g -2? This means that we're going to be looking at the graph of x, and we're going to be looking at the graph of g, and we're going to see, are both of them equal at x equals -2? Okay. So in order to do that, we're going to use our calculator here. Now, f of x, we're going to do it in red, and g of x, we're going to do it in blue. So let's actually graph f of x first. So let's get our calculator here. So we have our calculator. Let's turn it on, clear this. So let's graph it. Absolute value of x. To get the absolute value sign, you go to mathematics, you go to number, so you press to the right, and we press abs. So we want to find out the absolute value of x. So x, 0. So this is the absolute value of x. All right, let's get some points so we can graph it. Okay, again, once you graph it, if you want to get the absolute value, you go, if you want to get the coordinate points, you press second and table value. So this is the table value for the absolute value of x. Okay, so let me just draw the grid real quick here. All right, so that's our grid real quick. So now for the absolute value of x, we know that the graph looks like this. It's an absolute value. So if we get the point, second table, we get a coordinate point of 0, 0. We get another coordinate point of 1, 1. Another coordinate point of 2, 2. Another 3, 3, and so on. Well, let's see, do we have anything on the left side? Let's push up so we can get the negative x value. So negative 1, 1. Negative 2, 2. Negative 3, 3. All right, so these points are enough. You can see that the absolute value is going to be that B shape. So let's just draw our B shape. So here's our B shape. Oops. All right. So this is our absolute value right here. There it is. Perfect. Let's actually name it. Let's do f of x equals the absolute value of x. All right. So the red graph represents f of x. So now let's graph g of x. So let's come back to the calculator. Let's press y equals. Let's clear this. So you press clear. Now let's put the other function. Negative x to the second plus x. So now that we have it, if we press second table, we're going to get some values around here. So these are the table values for negative x squared plus 6. So if you want to look at the graph, you press it. So this is how our graph is going to look like. What we're going to do here, let's just be exact. So we press second table. These are some table values. Let me choose some points. Let's do, I have negative 3. You got negative 3. So when x is negative 3, you get y equals negative 3. So negative 1, 2, 3, negative 3, 1, 2, 3. So we got a point right here. Okay. Let me just do this real quick here. 1, 2, 3, 1, 2, 3. So that's negative 3, 3. Negative 2, 2. So negative 2, comma 2. Negative 1, 5. So negative 1, 1, 2, 3, 4, 5. 0, comma 6. So 0, 1, 2, 3, 4, 5, 6. Um, what is this? 1, 5. So we got x1, 1, 2, 3, 4, 5. And we got 2, 2. It's about here. And we got 3, comma 3. 3, comma negative 3, 1, 2, 3. All right, so these are our points. Let's just graph it real quick here. So, and again, just excuse my graphing here. Okay. So we got our line here. Let's just connect those points. All right, so let's actually name this graph. It says g of x equals negative x squared plus 6. So now let's see. In our both functions, are they equal at x equals negative 2? Well, let's see. When x is negative 2, notice that they meet, they touch each other, they intersect each other at x equals negative 2. So are they equal? Yes. So our answer here is yes. F of negative 2 equals g of negative 2 because they intersect at x equals negative 2. So we graphed it individually and we saw, well, what's going to happen at negative 2 when x is negative 2? We see that at x negative 2, both graphs intersect at that point. To be more specific, this is negative 2, comma 2. Because they do intersect, then we're going to say that f negative 2 equals g of negative 2. All right, so example 34. In example 34, we have the following here. It says two friends went to a restaurant and they order one plain pizza and two sodas. Cool. Their bill total 19. So two guys went into a restaurant and they ordered one pizza and two sodas. Let me actually put some letters to that. So they ordered one pizza and they ordered two sodas and their bill total 15.95. So this is saying that if we're going to build an equation, let's call this equation 1. Equation 1 is saying if you buy pizza and you add two sodas, you're going to be having a total of 15.95. This is what this line is saying. So now, if we continue reading here, it says later that day, now 5 friends went to the same restaurant and they order 3 plain pizzas. We're going to call that 3P. And each person had one soda. Now, if there are 5 of them and each one of them have an individual soda, so that means that they bought 5 in total. So we're going to have 5 sodas now. And their bill was 45.90. So we can actually create an equation here. So equation 2 oops, 1 second here. So equation 2, this is saying, well, if you buy 3 pizzas, so 3 pizzas, and if you add 5 sodas, that is going to be equal to 45.90. All right, so we have built 2 equations, but what is the question that we're trying to answer here? It says, write and solve a system of equation, which we'll do that in a second here. So we're going to write a system of equation, and we're going to determine the price of one plain pizza. And they want an algebraic solution. All right, so let's do the first one. Let's write a system of equations. So a system of equation, okay, sorry about the pen. A system of equation, what they mean is if you have created two individual equations, just put them together, and that's what we're going to call a system equation. So our system equation is called P plus 2S equals 1595, and 3P plus 5S is equal to 45.90. So this is a system of equations. Just literally put one function on top of the other. All right, so we have written, and now we want to solve a system equation to determine the price of one plain pizza. Now, if we want to solve, or if we want to determine the price of one plain pizza, pretty much they're saying in this system of equation, well, solve for P. Because we know that P stands for pizza. So if we want to solve for P, we're going to use our system of equation. So let's look at the system of equations, and you remember what we saw in class. Let's just look at the variables, so P and 3P. What we want to do is we're going to be looking at both equations, and we want to see if we can rewrite one variable in terms of the negative of the other. So what does that mean? Look what happens when you multiply negative 3 to both sides on the first equation. So if you multiply negative on the left and negative on the right, we're going to end up with negative 3P. Because again, what we're doing, we're just multiplying this, and negative 6S equals 15.95 times negative 3, that's equals to negative 47.95. Now let's rewrite the second equation because we have not done anything to it. Now, why did we multiply negative 3 on the top? Because notice that if you do that, notice what's going to happen if you add both equations now. Because again, you want to eliminate a variable. So that's why we multiply by negative 3 on the first, because now if we do that, notice what's going to happen with the p's here. If you decide to add the equations, negative 3p plus 3p, they will cancel out. They cancel out. The p's will cancel out. So now, if we add the s's, negative 6s plus 5s, that's negative s. And if we add negative 47.95 plus 45.90, it gives us negative 1.95. We want to solve for positive s. So what we can do, we can divide it by negative 1. This cancels out. So now that says that the soda is equal to $1.95. So have we finished the problem? No, we have not. Because the question is asking, we want to write and solve the system equation, and we need to determine the price of a pizza. What we have done here is that we determine the price for the soda. We don't know what the price of the pizza is. Now, to solve for pizza, so this is our system equation. So now, to solve for pizza, we're going to be using what we just found. So we're going to plug S to any equation. Perfect. So notice that in the system equation, we have two equations. P plus 2S equals 1595, and 3P plus 5S equals 4590. I'm going to choose the easiest. So I'm going to choose the first equation. And instead of writing S, I'm going to write 1.95 because we're going to plug S to any equation. So if we plug S to the first equation, we're going to get that P is equal to 2 times S, but we know that S is 1.95. And this is still equal to 15.95. Now if we do that, we're going to have P, oops, not an equal, but a plus, P plus 3.90. 2 times 1.95 is 3.90. And this is equal to 15.95. Let's solve for p. To solve for p, let's subtract 390 to both sides. So now this is saying that the pizza is equal to 12.05. So these are the prices. A soda is $1.95 and a pizza is $12.05. Let's just put the dollar sign here. Perfect. So this is our solution. This is P. This is the price of the pizza. Price of pizza. Okay, the price of pizza is okay. 12.5. Cool, perfect. We're almost done. Now, example 35 here. In example 35, it says Tanya is making some homemade greeting cards, and the data table below represents the amount she spends in dollars, f of x, in terms of numbers of cars, and she makes x. All right, cool. So here, x represents the number of cards, and f of x represents the amount that she spends. So x are cards, and f of x is what she spends. Now it says write a linear function, f of x, that represents the data. Okay. Now, what we want to do here is that it says that we need to write a linear function, f of x, that represents the data. Now, we've been given a table of values, and out of this table of values, we need to write a linear function. So when we're going from table to function, because that's exactly what they're asking us. They're giving us a table value and they're asking us to write a linear function. Well, I should not just say to function, but to linear. What we want to use, we will use something that's called linear regression. We will use a linear regression. Now, what is a linear regression? Well, a linear regression is done to you by the calculator. So the first thing that we need to do is put the table values in your calculator. To do that, we're going to hit stats and we're going to hit edit. In here, under L1, we're going to put the x values, and under L2, we're going to hit the f of x value. So let's put those values, 4, then 6. Let me just put those values here. Every time you put a value, you're going to press enter to go down. Now, these are my x values. Now, let me hit to the right. Now, here I'm going to put the y values, or f of x. So 750, 9, 1125, and lastly 12. So let's double check to see if they match. 4 and 750, yes, we have them. 6 and 9, yes, we have them. 9, 11, 25, cool. And 10, 12, perfect. So now that we have put the values in the calculator, what we want to do is we're going to hit stats again. But now this time we're going to go under the calculation option. And we're going to hit option 4. That says linear regression. Cool. We're going to press enter, and you're going to press enter one more time. So here, this is our function. This is saying that our function is y equals a of x plus b, and it's also saying that a is equal to 0.75, and it's saying that b is equal to 0.45. Oops. There it is, 0.5. So now, the linear function is y equals a of x, but it's saying that a is 0.75. So our function is going to be y equals 0.75 x plus b, but we know that b is 4.5. Perfect. So this is our linear function here. Y equals 0.75x plus 4.5. And again, when you see that you've been given some kind of a function and you want to find out the linear function or the linear representation of this function, you got to use linear regression, which is done in the calculator for you. So now there's also an extra step here. It says, well, now that you have this function, let's explain what the slope is and what the y-intercept is. All right, so we have a function. Notice that the slope is the number that's in front of x, which is going to be 0.75. Okay, perfect. So now let's explain what 0.75 means. Now, usually slope is the rate of change. So it's pretty much what is changing. And if we look at the problem, well, let me write this down. Slope is the rate of change. So here it's saying that the rate of change is 0.75. Well, let's see, in our problem, what do you think is going to be changing here? Well, it says Tanya is making homemade greeting cards. The table below represents the amount she spends in dollars in terms of the number of cards that she makes. Okay, so if we look at here, notice that something that is going to keep changing as time goes on is pretty much the amount she spends on each car that she makes here. So what is changing in this problem is going to be the amount spent for each car that she is making here. So we know the slope is 0.75. Now they're saying that we need to explain this. So in this case, 0.75, what this represents the amount spent for each card. That Tanya makes. Now for the y-intercept, which in this case, the y-intercept is the number that it's by itself, which is 4.5. Usually the y-intercept is the fixed point. It's a fixed point because it's not changing. It's always going to be 4.5. So if we know that 0.75 is the amount she's spending for each car that she makes, then that means that the y-intercept, this represents a fixed cost. Okay, so this concludes part 5 of our Algebra 1 Regents review.